on what we call the examples. Let's look at the examples for a cubic function, right? Remember that when you talk of a cubic function, you've got the following equations. You've got f at x equals ax cubed plus bx squared plus cx plus d. And then there's another one. This one here, it's a into x minus x1 into x minus x2 into x minus x3, right? Remember that we are using this one only when you have the x-intercept. We are using this one when you have the x-intercept. It's x1, x2, x3. Those are the roots. And again, when you look at this Cartesian plane here, you might find out that you have the x-intercept, which is equal to 0, also the y-intercept, which is equal to 0. And you might find out that those are only the roots that you have. X is equal to 0. So in that situation, for instance, if your graph is to increase, it would go past where x is equal to 0 up. But that doesn't mean the graph won't have the turning point. You might find it like this, but it doesn't touch the x-axis. It only touches the x-axis where x is equal to 0. Also, again, you might find a graph which might be looking like this one. Again, it cut x once. So that means it will have only one x-intercept, but two turning points, as you can see there. So if, for instance, you are solving to find the x-intercept, let's say you have h at x equals ax minus b into ax squared plus bx plus c, which is a quadratic, right? You might find out that you are able to solve for x on the first bracket, but here you find out that there are no roots. If there are no roots here, that means, if there are no roots here, that means your graph might be looking like that one or like this one. Second bracket has got no roots. You can't factorize the second bracket. So your graph might be looking like one of the two. You can solve for x on the first bracket, but here you are unable to solve for x. That means your graph will be looking like that. Right. And again, you might find a graph like this one. Let's say this is the function of f, our turning point, and also our turning point, and our y-intercept. It says A, B, C, and D. Right. When you look here, we've got the x-intercept there. The same x-intercept is a turning point. So on that situation, that will mean at point B, you will have two equal roots. If you are to find the x-intercept, you will get two equal roots there. which means, let's say for instance here, x1 is equal to 2. You might find out that also x2 is equal to 2. So that means your graph, if you've got two equal roots, that's where your turning point will be. It indicates that your turning point will be there if you've got two equal roots. And then the turning point there, this one won't be the same as that one, as you can see. Right. Let's go to examples.
Given f of x equals to x cubed minus 12x plus 16.
Right, that's our given equation.
The first question, show that x minus 2 is the factor of f of x.
So if we are to find or to check if x minus 2 is a factor of this, remember that our given equation, it's x cubed minus 12x plus 16. Remember that when we talk of a factor theorem, we said this, if you are to substitute with that value of x, it has to give us 0. This equation, it has to give us 0. So you are being given that f of x is equal to that, and you are to see if x minus 2 is a factor of that. It's simple. I said you equate these to 0. You equate these to 0. Let me write the question there. Let's say it's the first question showing that x minus 2 is a factor. Is a factor here. We are to show that x minus 2 is a factor. Simple. You equate this to 0, so our x is equal to 2. So we're going to take that x value and substitute it here so that we are going to check what will be the remainder. It's f at 2 equals 2 cubed minus 12 times 2 plus 16. And then the answer here, it will be 8 minus 24, that is minus 16. Minus 16 plus 16, that will give us 0. So our remainder is 0. That means x minus 2 is a factor. You write the conclusion. Therefore, x minus 2 is a factor. X minus 2 is a factor, simply because when you substitute it here, the remainder is 0. Let's move to the next question.
This question, factorize f of x completely.
We are to factorize f of x completely. Right. So you have the first factor there. It's f at x equals x cubed minus 12x plus 16. So let us factorize this. We've got the first factor, which is x minus 2, simply because it gave us 0. So it's x minus 2, our first bracket. And then we are to find the second bracket. Let's look which value we can multiply it to x to find x squared. That will be, x cubed, that will be x squared. Right. We do not have something with squared there. So, but here you are going to have squared. It's minus 2 x squared. So for you not to have x squared there, you will have to say plus 2x squared. Therefore, you add 2 here. It's plus 2x. X times 2x, that will give us 2x squared minus that 2x. Right now we are looking for the value that we are going to multiply it with negative 2 to find the last term. Therefore that will be negative, it will be negative, that will be minus 8. It's minus 2 times minus 8 to get positive 16. And then you are being asked to factorize. So let's find the factors there. It's x minus 2 into x minus 4. It's x minus 2 into x plus 2 into x minus, or we are to find that as positive, so it's minus here. It will be plus minus, it's minus and plus 4. Let's check. 4x minus 2x, it will give us that, right? Those are the factors. You're being asked to factorize f at x. So that's how our factors will be. When you look here, we've got two roots that are the same. Remember that I said when you see this, you bear in mind that you are going to have a turning point here, simply because the roots are the same. The roots are the same here. We are going to find two equal roots. Let's go to the next question.
The next question, determine the x and y intercepts of graph of f.
You determine the x and y intercept of the function of f. Of the function of f, right? Our equation again, we've got f at x equals x cubed minus 12x plus 16. Let us first find the what we call the y-intercept, because it's simple. For y-intercept, you always let x to be 0. We are to let x to be 0. So this will be 0 minus 12 times 0 plus 16. Then the answer will be equal to 16. Right? We are to find the y-intercept. Therefore, the y-intercept, our y-intercept will be this point. 0 is to 16. That's our y-intercept because it's a point. It's 0 is to 16. Let's find the x-intercept. For x-intercept, we are to let y to be 0. Our y is f, remember. Therefore, in our equation, because we have factorized it here, let us write it as it is. We are going to have x minus 2 into x minus 2 into x plus 4. This will be equal to 0, and then you solve for x. X is equal to 2, or x equals 2, or x equals negative 4. These are our roots. Let's write the x-intercept. Our x-intercept will be 2. If x is equal to 2, y is 0. Again, we've got 2 is to 0. And then the last one, it's negative 4 is to 0. Those are our x-intercept. The x-intercept are the points where the graph cut the x-axis. Right, let's continue. That was our third question.
The next question, sketch the graph of f.
We are now to sketch the graph. We sketch the graph.
Here, label all the intercepts on the axis, the coordinates of the turning point, and the coordinates of the point of inflection.
So you are to sketch the graph of f. Remember that for you to sketch a cubic function, you need the following points. Number 1, it's the y-intercept. Number 2, x-intercept. Number 3, the stationary point. The stationary point. So once you have this, you can be able to sketch your graph. And remember that the other thing that is much important when you talk of sketching a graph, it's the shape. The shape of the graph. So the shape of this function, when you look at the value of a is greater than 0. That means the shape, it's an increasing function. That's how the shape will be looking like. So let us sketch our graph. For us to sketch a graph, remember we need those points. We do not have the stationary point yet here. So let's find the stationary point. The equation x cubed right, let's find the stationary point. For stationary point, we will have to derive this function. And then after, we'll let the derivative to be 0. Remember that the derivative is a gradient. So the gradient of a function at a stationary point, it is equal to 0. Let's derive. 3 times 1 here, it's 3. And then we subtract 1 up there. So we are going to have 3x squared minus, it will be minus 12. We derive with respect of x, so we forget about 16. And then after, this is a gradient at the turning point. So we let the gradient to be 0. The gradient of a tangent at a turning point is equal to 0. Therefore, we are going to let the derivative to be 0. 3x squared minus 12 will be equal to 0. Let's divide by 3 here. It's x squared minus 4 equals 0. Difference of 2 squares. X minus 2. It's x minus 2 into x plus 2. The difference of 2 squares. Therefore, x is equal to 2 or x equals negative 2. These are the values of x at the turning point. So we are now have to find the y value at the turning point. For y value at the turning point, you substitute these x values into the original equation to find the y values. For y value at the stationary point, substitute the x value into the original equation. Let's do it. It's f at 2. We are substituting there. It's 2 cube minus 12 times 2 plus 16. And then the answer. So the answer is 0. The answer is 0. You will remember the shapes that I've drawn at first here. Right? Let's find f at negative 2. You have to use the two values of x. F at negative 2. It's minus 2 cubed minus 12 times negative 2 plus 16. And then the answer will be 82. Right. If x is equal to negative 2, y is equal to 32. If x is equal to positive 2, y is equal to 0. Let's write the stationary points. You do not leave it there. You need to write the points. Right. Therefore, remember, stationary point is a turning point. Our turning point, we've got two turning points. We've got this one. If x is equal to 2, y will be 0. So it's 2 is to 0, x is to y. The other one, if x is equal to negative 2, y will be 32. So it's negative 2 is to positive 32. And then we've got all the points now. Y-intercept, X-intercept, stationary point. We are not being asked to find the point of inflection. So just find these points and then sketch the graph. Right. The value of A is positive. So the shape of the graph, it will be an increasing function. It's an increasing function. This is the function of f. And then let's look for the x-intercept. Our x-intercept, we had a 2 is to 0, 2 is to 0, and negative 4 is to 0. So, obvious, this is on the right hand side of the y-axis. This is on the left hand side, which is our second quadrant. Again, up there, when you look, we've got the turning point. We've got the turning point where x is equal to 0. We are going to have the turning point. Also, if x is equal to negative 2, we are going to have that turning point there. So you need to draw your Cartesian plane. The y-intercept. The y-intercept is 16. So the 3 points, it's x-intercept, y-intercept, and our stationary points, as you can see up there. So let's write our graph. It's an increasing function as I've indicated the shape. Remember that we have a turning point there where x is equal to 2. We are going to have a turning point. And again, our graph is increasing. Let's write our y-intercept. It's 0 is to 16. That That's where the graph will cut the y-axis. We've got the x-intercept, which is 2. 2 is to 0. The other x-intercept is here, which is negative 4. Let's say we've got 4 there. Right. This is our y-intercept, x-intercept, x-intercept. Right. Since we've got negative 2 as a turning point, that's why we need to have that negative 2 there. So, if y is equal to 32, x will be equal to negative 2. Right, let's try to stretch our y-intercept there. Right, and let's say this is 32. If y is negative 2, if x is negative 2, sorry, y is equal to 32. This is our x-intercept. Goes up there to that point. And again, there is a turning point there. 2 is to 0. X is 2, y is 0. Let's see our graph. Let's join the points. This is the function of f. And then after sketching your graph, you label the points. Here it's negative 2 is to 32. Here we've got 0 is to 16, our y-intercept. Here we have 2 is to 0. Here we are going to have negative 4 is to 0. So your graph is complete. That's how to sketch your graph. Remember, you need to be careful of the shape. This is an increasing function because the value of a is positive. Right. You can indicate the point of inflection if you are being asked to also find the point of inflection. But then here you're just being asked to sketch the graph. So we need the x and y intercept, also the turning point. Right, let's proceed to the next question.
Consider the function of f defined by f at x is equal to x cubed minus 6x squared. Defined f at x equals x cubed minus 6x squared.
Right, that's what we are being given. And then let's look at the next question.
This question, find the intercepts of the graph of f with the x's.
We are to find the intercepts
Of the graph of f.
we are to find the intercepts of f with the axis. The intercept of f with the axis. Remember that we have the x-axis and the y-axis. We have the x-axis and the y-axis. This means that you are to find our axis. It's this point, that point, and that point. You are to find the y-intercept, the x-intercept. Right. This is the equation that has been given. Let's quickly find the y-intercept. We have this equation, f at x equals x cubed minus 6x squared. Right, for y-intercept, we always let x be 0. And then let's see, it's 0 minus 6 times 0. And then the answer here is 0. Therefore, our y-intercept will be given by this point. 0 is to 0. X-intercept is 0. When x is equal to 0, our y is 0. Let's find the x-intercept. Right. Our equation is f at x equals x cubed minus 6x squared. Remember, we are to find the x-intercept. For x-intercept, we let our y to be 0. Therefore, it's x cubed minus 6x squared equals 0. And then the next step, we need to factorize this. The factors here, let's take out the common factor, which is x squared. When you take out x squared, then you'll be left with x minus 6 equals 0, like that. And then after factorizing, you solve for x. So it's x squared equals 0, or x minus 6 equals 0. So obvious here, x will be equal to 0, or x equals 6. So this is the value of x. Let's write our x-intercept. 0 is to 0. And the other one, we've got only 2. The other one is 6 is to 0. Right, those are our x-intercept. When you look at this point, we've got also y, where our y-intercept is 0 is to 0. Which means this graph will cut y at 0, and there will be also another point where it will cut x at 0. Let's find the stationary point then, because we are done with the